In this particular question, we've been given the quadratic function y equals x squared minus 4, and we've been asked to find the area between this function and the x-axis in the interval from 0 to 4. So what we start by doing is graphing our quadratic function. Its vertex is going to be at 0, negative 4, and it's going to have two zeros. One is going to be at negative 2, 0, the other one at 2, 0. Now, what makes this function different from the other functions that we've encountered is that the other functions that we encountered have always been positive functions, meaning no portion of the function lay below the x-axis, at least in the interval in which we were trying to determine the area under the curve for. But that's not the case here. You can see that from 0 to 2, our quadratic function lies below the x-axis, whereas from 2 to 4 it lies above. So we're going to have to handle this question slightly differently than the other questions that we've handled in the past. If you attempted to find A1, the area between the curve and the x-axis in the interval from 0 to 2, by merely taking the definite integral from 0 to 2 of our function x squared minus 4x, if we attempted to do that, what you would find is that the area you would get is negative, which doesn't make any sense. You shouldn't have a negative area. So how do we get around this? What we want to do is find another function whose area between that curve and the x-axis would be the same in this interval from 0 to 2, but would be positive. Well, how could we accomplish that? What we could do is, instead of dealing with the quadratic function y equals x squared minus 4, we could deal with the quadratic function y equals negative x squared plus 4. What we've done in that case is reflected the function in the x-axis, and by doing so, when we work out that area, A1, it's going to give us a positive answer. So A1 is going to be the integral from 0 to 2 of negative x squared plus 4 dx. We take the antiderivative of that and we evaluate it. And what we find is that A1 is equal to 16/3 or 5 1/3 square units, or units squared. So we did get a positive area like we desired. Now we still have to work out A2, but we don't get into those sorts of problems with A2 because in that particular portion of the curve the function is above the x-axis, so we don't have to deal with the reflection of our original function. So A2 will be equal to the integral from 2 to 4 of x squared minus 4 dx. We take the antiderivative and evaluate it, and we get 10 2/3. That's the area of A2. Now to get our total area, all we do is add A1 and A2 together, and what we end up with is 16 square units, or units squared. That is the area between this curve and the x-axis for the interval from 0 to 4.